So today I'm going to talk about kind of this unique project that we have going on that we've been involved in the Albany, Georgia area. And it is a multi-agency project, including private landowners. We have all come together to coordinate our smoke better or manage our fires better to have better smoke management in light of, not only government regulation, but human health. So briefly before I get into it, in case you're wondering or haven't heard about Tall Timbers and are curious about who Tall Timbers is, we are a nonprofit that started in 1958. We are a research station, and our mission is to really bring science, down to the land management level to really affect change at the beginning and on the ground with people. And so we are involved at several different levels nationally. We are engaged in fire research. We're doing that research. We're publishing papers. We have extensive fire training where we're teaching what we know to people, how to manage for fire, smoke, management outcomes. And we're also talking to government officials. We're talking to Congress, the representatives and the senators to try and get policy to keep prescribed fires going as a tool for increasing biodiversity and reducing wildfire risk. We are stationed, our main campus is in Tallahassee, Florida. So we are focused a lot on Southeast issues as well, a little bit closer to home. And we're looking at how to put prescribed fire on the ground, particularly in the Southeast, and management of quail, which is a game bird I'm going to talk a little bit more about coming up, and declining species that really depend on fire because the Southeast, for centuries, we've had regular fires, whether through lightning ignited wildfires or fires set on purpose, those prescribed fires. We are a heavily fire managed landscape, and these species we have depend on it. And more locally, kind of the area I'm in, I'm just to the north of Tallahassee. We call it the Red Hills region. And one of the places I'm going to be talking about today, Albany, Georgia, and not too far away from here, about an hour and a half in a car. These are kind of our core research areas where we practice, what we've learned and what kind of research can we apply on the ground, what kind of policy changes need to be done, and how can we train people to really take care of this land that we have that's heavily adapted to fire. So that's just an overview of what we do here. But as I've already mentioned several times, we study prescribed fires, and those are fires that are set on purpose for specific land management objectives. So a lot of times when I talk about fire, if you're not familiar with prescribed fire, you think wildfires. So it's what you see in the news, the houses being burned down, really out of control fires, smoke for days. But that's not what prescribed fire is. So it's a much gentler process or less severity as when compared to wildfires. But in the Southeast United States, we set a lot of these fires. So this particular image is from the National Association of State Foresters, a report put out by the Coalition of Prescribed Fire Councils every few years, where they survey state foresters and ask, hey, how much did you burn this year in prescribed fire? And you can see that the Southeast really sticks out. We burn a lot down here. For example, where I'm in the state of Florida, we burn about 2 million acres every single year in prescribed fire. Again, that doesn't include wildfire. And the state of Georgia is very similar in the amount they burn. And I'm going to be focused on Georgia today for this talk, but Georgia is in the top 5 states of prescribed fire acres. And it's just not according to this survey that we see it. There's another data set we could look at, and this is prescribed fire permits. So a lot of these southeastern states and other states, when you want to have a prescribed fire, you have to get a permit from your state forestry agency. Now, each state is different. Some states don't even require it. Each state has a different rules and regulations. So they operate separately. And up until recently, there was no one place you could go to get all this information. So a couple of years ago, Karen Cummins, who's the director of the Geospatial Lab here at Tall Timbers, compiled this report, got all of those data sets together in one place, and looked at what's the state of prescribed fire according to these burn permits. And so this is a heat map that she created using those points weighted by area. And these areas you see, the one that's kind of in central northern Florida, southwest Georgia, that's the Red Hills and the Albany area. So fires that are occurring in these prescribed burns are both on public and private lands. So here is just breaking it down by public lands. And what you see when you focus on the state of Georgia is you see burning on public lands that are your forests, your state forests, and your military bases. So that is that's what you see in this figure. But when you start looking at private lands, most of the lands in the Southeast are actually privately owned. I think about 80% or so. So we see a lot of private land burning. And here, those hot spots again, that one with the white, that's the Red Hills region. And that one kind of up to the northwest of that main area, that's the Albany area. So these are managed for, endangered species and private quail lands. So there's some other reasons why fire is needed in the Southeast landscape and why we burn so much here, as I've already kind of alluded to. We've got lots of threatened and endangered species that require frequent fire. So all of these guys right here, whether they're plant or animal, they are used to fire and they need that clearing of the fire every couple of years so they have room to move around, but they still have cover from their predators, or maybe the plants that they lay their eggs on or they feed on are fire plants that need that fire to start blooming. So that's one of the reasons why we burn. And another one that I've already alluded to a couple times is game habitat. So I'm going to point towards the northern bobwhite quail here. That's a big reason for burning in the Albany area that I'm going to talk about a little bit more detail. But like I mentioned before, it's the same with the threatened and endangered species. They need cover for hiding from their predators, but not so much cover that they can't run around. Otherwise, they will not be able to survive in that habitat if it's not regularly cleared out by prescribed fire. And then, of course, a big one is wildfire hazard reduction. So if you look at this image right here, this is in longleaf pine, which is a fire adapted species we have here. And if you've never seen prescribed fire before, this is a pretty good image of it. It's not that big, high smoke event you see on the news. It's not consuming the trees. So fire has already passed through the foreground, and all those kind of juvenile longleaf pine trees, they're still standing, they're okay. This is just a low severity fire that comes through every couple of years, cleans out, fuel on the ground, dropped pine needles, some saplings that have grown up that are going to choke out some of the animals that live on the ground or some of the more endangered species we're burning for. So it just gives it like this nice open look and gets rid of all that accumulated fuel and all of those nuisance trees that are sprouting up that we don't necessarily want. But of course, fire is still fire. So prescribed fire, we have smoke. And so smoke is a concern. Why do we worry about it? Well, smoke, if you've never really thought about it, it actually has multiple components to it. We have water vapor, different hot air and gases that are in it. And the ratio of all of these things depend on what you're burning, what your fuel load is, your burning conditions, and even what state of the fire you're in. So if you're in that flaming front that comes through, you might get a lot of smoke all at once, but then it clears out. But if you are in that smoldering where it's kind of left behind and it's still kind of warm and it produces a lot of smoke, you're going to get a different ratio of some of these components. And in particular, what we're concerned about and what I'm going to be talking about mostly today is particulate matter, or PM and PM 2.5, which is particulate matter that's 2.5 microns or less in diameter. So if you've ever heard anybody talk about PM 2.5 before, you've probably seen this figure, because it's really hard to imagine just how small PM 2.5 is. So this particular cross section is a human hair. So you could fit 20 of these PM 2.5 particles across the width of one human hair. So they're incredibly small. This image was put out by the Environmental Protection Agency. And because they're so small, they can bypass a lot of your body's natural defense systems to, your nose hairs and everything like that. That kind of stops a lot of those bigger particles, and it could penetrate deep into your lungs, and it could start interacting and entering your bloodstream. So now fires aren't the only source of PM 2.5. If you're in larger cities, your largest source is going to be anthropogenic sources, vehicular exhaust, factory emissions. But no matter, if it comes from fires or anthropogenic sources, it has still been linked to some negative health outcomes. Everything from, asthma exacerbation, COPD, to even premature death. So because it has been linked to all these negative health impacts, it has gotten on the radar of the Environmental Protection Agency as a pollutant of concern. And so, as part of the Clean Air Act and the National Ambient Air Quality Standards, they want to mandate how much is in the air that we breathe here in the United States. So, with some other ones, such as lead and ozone, they put a limit on how much they consider safe in an airshed for everybody to breathe. And that's part of the National Ambient Air Quality Standards, or the NAAQS. So PM came online about 2000 as being something that they're concerned about and they want to lessen. So they put in several different standards. They have a daily annual average they do not want a certain airshed to exceed. And they also have an annual average that they don't want anyone to go over. So for years, the annual average for PM 2.5 in the United States has been they don't want any airshed higher than 12 micrograms per meter cubed. And they monitor this by a series of sensors they have. Usually in more heavily populated areas is where the EPA will put their sensors. And so since that, this figure right here shows that since they've implemented the NAAQS and they've had these standards, that all of these pollutants of concern, they have steadily declined in the United States. So as part of the Clean Air Act, every few years they can revisit it. So they revisited the Clean Air Act recently, and they lowered the national annual PM 2.5 standard from 12 micrograms down to 9 micrograms per meter cubed. And so now with that lowering, this figure is just focused specifically on monitors in the Southeast United States for PM 2.5. And you can see for many years, we've been comfortably below that dashed line, which was the previous standard. But now with this new national standard, on average, we're pretty close to it, which means that some areas are going to be above that new national standard. And if you're above that annual average, you're going to have to make, some plans and file some things with the government to say, this is what we're going to do to get down to this healthy level. And it could put extra burdens on certain states and certain airsheds to make sure that you're not consistently going above this 9 microgram per meter cubed standard. So when EPA was first examining all of this, they wanted to see what is it going to look like across the United States. And for us, we're going to what does it look like in Georgia if this new rule were to take effect? So the EPA made this map using 2019 to 2021 data when they were first examining this rule and what to lower it to. And I will say, when I say an annual average, it's actually 3 years that they average together. So that's why they're looking at 2019 to 2021 monitoring data. And we could see, if we look at the state of Georgia, there are several counties that they said, if we did implement this new 9.0 rule, these counties are going to be out of compliance according to our regulation monitors. But it's a little bit more complicated than that. So once these designations were made, it's up to the state air quality agencies to kind of dive into more detail with this. So this is from Jim Boylan with the Georgia Environmental Protection Division, who's in charge in the state of Georgia of implementing this rule and examining what airsheds are in or out of compliance. And not only is it the sensor that might be out of compliance in the county the sensor's in. So each one of these blue dots is an EPA monitoring station, but any of the surrounding counties that are deemed that contribute to that overage at that particular sensor are also considered out of compliance and are also included in any regulations that might come down from the state or the federal level. So if you're looking at this, there's a lot of counties in Georgia that would be out of compliance with this 9.0 rule. Now, some of the questions you might get when you think about what's impacting an airshed, like what enters in, you might naturally think of wildfires. So we had a lot of Canadian wildfires a couple of years ago. Some of that smoke even reached us down here in Florida, and it sent our sensors way up. So you might think, well, how is it fair? If for a state to get penalized for having, excessive PM 2.5, but if it was smoke from Canada, you can't really stop it at the state line. So the Clean Air Act does acknowledge that these things happen. And so they allow you to file what's called an exceptional event. And so an exceptional event is something that's unusual or naturally occurring, like a wildfire, and you can't control it. So they don't want to penalize states and airsheds for having something that they can't control, like a wildfire. So when the state air agency identifies some of these events, what they can do is they can file with the EPA. And so they gather all this justification documentation. So they look at, hey, what's our past? If we look historically, what typically do we see this time of year as far as our PM 2.5 levels? And then they compare it to what they observe for the days they're trying to file as an exceptional event, saying, okay, normally we're not like this, but because of this event, we had all this PM 2.5 in our airshed. And then they run some models, like we can prove that this particular event, moved in by running something high split or like a dispersion or smoke model to prove that it moved over the area. And then they write up a little report. And so once they have all of this, they have to open it up for public comment. So anyone can comment during this period. It can be anyone from the public to environmental groups that may agree or disagree with their justification documentation. They can list out the reasons they agree or disagree with it. And then the local state agency, they must respond to all the public comments. And so they submit the justification documentation, the public comments, their responses to the public comments to the regional and national EPA for approval. And so the regional and national EPA, they review all of this documentation. And then if they approve it, they disregard those days from the calculation. So that's how they remove these exceptional events. So they'll take those days out and recalculate what the annual average would be without those exceptional events that impacted the air that day. Now, prescribed fires can be an exceptional event according to the EPA. They do recognize the benefits of prescribed fire, but part of the problem is up until recently, and things change every day. So while I'm talking, they might come out with a review of it, but there's only been one exceptional event for prescribed fire that was submitted and accepted, and that was for a demonstration out in California. And it was a single fire event, and it was about 60 to 100 pages of documentation they had for one fire. Now, when you're talking somewhere like Georgia, where we burn maybe, up to 2 million acres a year in prescribed fire, that's a lot of exceptional events you would have to file. So, for example, between wildfire and prescribed fire events, and in this exceptional events process, they would have to file 151. So with this, up to 60 pages per event, the Georgia EPD worked very closely with the regional EPA to come up with a new method. So they didn't have to do 60 pages per event for 151 events. But either way, even if they come up with a new method and it gets accepted, it's still really time consuming. And not only that, where we burn where we live. So we're setting these prescribed fires. We're also in the air. We also care about our health. So wouldn't it be great if we could find a way where we could balance both? We need prescribed fire. We also want clean air. So can we kind of find a way to manage ourselves and come up with new methods to balance the need between the two? And so that's where the Albany Pilot Project really came from. So this Albany Pilot Project, we're focused down here in Albany, Georgia, right? And this is an area that has a lot of prescribed fire. So that's why we chose Albany. And again, I promised I would bring them back up. And here's the northern bobwhite quail again. This is a really big reason for a lot of the burns around Albany. And according to whyprescribedfire.org, which is a website that we have at Tall Timbers to inform about prescribed fire, this management for the northern bobwhite quail and the game properties alone account for 1,000 local jobs in this rural community. Anything from land managers to tour guides, outdoor guides, farmers, operators, and it brings in $145 million to the local economy. So it's a vital part of their economy. And if prescribed fire would stop, they would stop managing for the hunting properties, hunters weren't coming in, it would be a significant blow to the local area. And not only that, but it's just not northern bobwhites that are on these properties. A lot of these land managers, they've been around for generations. I've talked to land managers whose fathers managed the land down the road, and their grandfather retired from another area down the road. So these are lifelong people that really care about what's going on, and they care about all these endangered species, and a lot of them have them on their property as well, in addition to the northern bobwhite quail. And so that's why in a period from about February to April, they burn almost 150,000 acres a year in kind of this 30-mile radius around this town. That's in between hunting and nesting seasons for the bobwhite quail. So today I'm going to be talking about the Albany Pilot Project 2.0. There was a 1.0, but I'm not going to cover that for time. But as I said at the beginning, this was really a multi-agency approach. One of the people that really drove it was the Albany Quail Project. They are an offshoot of Tall Timbers that's on Pineline Plantation, which is one of those hunting properties. They recognized, we care about our air and we care about prescribed fire. We need to manage ourselves. We need to find a better way to balance everything. So we worked with the Georgia Forestry Commission and the Jones Center, which is another research organization that's up in that area, very similar to Tall Timbers. And we said, how can we bring science to this pilot project? How can we use smoke weather? Because there's certain weather conditions that are more ideal to burn under than others. How can we use that to our advantage? And so we came up with basing everything pretty much on the transport wind. So the transport wind, if you're not familiar with it, that's what moves the smoke. It's just not what you're feeling at the surface. If you've ever been out and you see smoke plumes, you kind of see they go up and sometimes they stop and then they flatten out and go along. That's like the top of the mixing layer. So that's where all your convection's going. That's where the smoke in the air is mixing. And so that transport wind is the wind from the surface all the way up to that layer. And that's what's moving your smoke. So we said, okay, if you've got a transport wind, for example, this is coming out of the southwest. So any of these areas that are burning to the southwest of Albany, which is the largest city in this region, that smoke is going to pass over that city. So how can we keep as much smoke from entering that airshed as possible? And we came up with this flow chart right here. So if you are within this cone, which is 30 degrees on either side of the transport wind vector, and you want to get a permit to burn, you're going to have some more regulations to go through. So if your transport winds are low, or you're something else called smoke dispersion, which is just a measure of how well that smoke is going to move out of the area and become diffuse. If both of those are low, they're going to ban burning that day. Or if there's already a lot of PM 2.5 from the day before, you're not going to be able to do any forest burns or land clearing burns that day within the cone. It's not going to, your smoke's not going to move out of the area. It's going to linger. And then as the transport winds improve or your smoke dispersion improves, you can burn more and more acreage. So the idea behind this tiered approach was you could see these properties outlined here. Some of these properties are really large and they have, a burn crew behind them. But we also have a lot of those private landowners. Remember earlier I said about 80% of the land in this area is privately owned. And they manage their land with fire too. So the idea is on these more marginal burn days, we can let the smaller landowners that maybe have their friend or a part of an organization that comes and helps them burn, they can get their smaller acreages out of the way so that on the days where it's really great smoke weather for clearing out all the smoke, that the bigger land managers can burn. And also, we wanted to manage kind of just that 30 miles around it. So if you're not directly in that cone where the transport wind's going to move your smoke right over it, you still have additional regulation. I should add these regulations are in addition to anything else the Georgia Forestry Commission has that day. Like, if there's a drought or anything like that or a fire weather warning, they will take all that into consideration. But it's a little bit less onerous, but there's still some restrictions on how much you can burn. So the next question is, how well did this perform? Because this was enacted in January 1st of 2025 and ran through the entire calendar year. And so I have some preliminary data, and I say preliminary because the official PM 2.5 data from Q4 is not in yet. So we're using provisional data there. And this figure right here, there's a lot going on, but you will see there's some gray lines. Those gray lines are historic daily running averages per quarter. The EPA calculates per quarter and then averages the quarters together to get a yearly average. So that's mimicking what the EPA does. So those gray lines are historically what has happened. That dark blue line is what happened in 2025. And the shaded rectangles and the numbers along the bottom, the Q1 average through Q4 averages, those are historic averages. Those are what we observed over the last 10 or 12 years. And so what we can see from the historic averages is that historically, Albany is about 9.2 micrograms per meter cubed every year. So just above the new threshold of 9 micrograms per meter cubed. So we had a little bit of work to do. And in 2025, you could just note, looking at the lines, that everything was actually below the historic quarterly averages, and some were well below the historic quarterly averages. And so we ended up with an average annual estimated, and I should, again, Q4 is provisional, of 8.4 micrograms per meter cubed. So well below the historic average and comfortably below the new 9.0 microgram per meter cubed standard. But I will caution that further investigation is needed. We're not sure if all of this is exactly tied to the pilot project. There was droughts in quarters 3 and 4 that curtailed burning. And we also just want to see if the meteorology was different. Was there something different that year versus the historic years that just made it incredible burn weather for everybody in the region? So that's all ongoing analysis. And of course, another question is, well, did people just burn less? Did the restrictions cause them to not be able to get their burns completed? So I'm going to go through this slide kind of quickly so we have more time for question and answers. But the short answer is no, they actually burned more. So within the 30-mile buffer in 2025 compared to the previous 2 years, they burned 2 to 5,000 more. So about 3,000 more acres than in 2023 and 5,000 than in 2024. And if you look at, if we would have had a cone in 2023 and 2024, which we didn't, but if we would have put a cone there, we could see that whether through permitting being denied or just Albany Quail Project and the Georgia Forestry Commission doing a really great job of spreading awareness to all the local land managers that, hey, we're going to manage our smoke better. We've got this pilot program. Let's stick to it. There were fewer permits and fewer fires that were inside the cone. And most of them were outside the cone, meaning that it's not moving over the town of Albany. And so this is really hinting at a change in burn behavior that's occurring. And so we are very encouraged by this and we're continuing on. I'll talk about changes to the pilot program in a little bit we've made for this year, but of course this is a LANDFIRE office hour. So how is LANDFIRE playing into all of this? Well, this is some ongoing analysis that my lab is doing right now, is how can we show that this pilot project is effective, or maybe we can tweak it. Right now we go out, we have that 30-mile buffer. Maybe we don't need 30 miles. Maybe we need 20, or maybe we need 50. Maybe we don't need a cone that's that big. Maybe we can make it smaller, but you can't do that in real time. I can't go out and control the weather and have it change and see what I want without doing some modeling. And so that's where LANDFIRE comes in. So we're starting this modeling process to test how effective the pilot project is and see if we make adjustments to it, if it would be even better. And so one of the data sets we pulled in, I talked about at the beginning, is this prescribed fire permit database, where we have all the locations of prescribed fire that's occurring in this 30-mile radius in Albany. And then for LANDFIRE, we're pulling in the existing vegetation type layer, or the EVT. What is actually burning? Now, when you pull a permit, you give a general category like silviculture, which means, it's under a forest, or agriculture. But with EVT, we can really get at what, according to the data, is actually burning. And I should put a caveat in here that we are using cropland data layer. If EVT flags it as agriculture, cropland data layer is not a LANDFIRE product, but it will tell us what kind of crop was burning. And one of my favorite LANDFIRE data sets to use that's really crucial in this is the Fuel Characteristic Classification System, or FCCS. So you can get fuel loadings from that. So when I'm trying to run a smoke model, you have to know what the emissions are. And the only way you can know the emissions is if you know the area, you know the fuel loading, which means how much fuel burned, how much fuel was accumulated when this fire came through, and then something called emission factors. So for PM 2.5, it would be how many grams of PM 2.5 are emitted if I burn 1 kilogram of conifer forest fuel type. And what's great about FCCS is that it has different strata of fuels. So as I talked about at the beginning, prescribed fire is just along the surface. You don't see it burning down trees or what we call crown scorch when you see the wildfires where it gets up into the top of trees. It's staying along the ground. So because FCCS has different strata, I can pick to not include canopy fuels, but to include all the fuels on the ground that go into that fuel loading. So it is more reflective of what is actually burning versus some other fuel loading data sets that just group it all together. Because I'm definitely not burning crowns on the tops of trees. I'm burning ground cover, and I have that kind of control with FCCS. So we haven't started a precise modeling yet. We use something called high split in my lab to do that. But when we're focused right here, the results I'm about to show separate things in and out of the cone. So again, that's just a reminder of what a cone would look like. We can see using EVT what is allowed and what's not allowed. So this is looking at 2023 data with LANDFIRE. We went with 2023 because it had no pilot program going. So 2025 data obviously would have been skewed by the pilot program in place. And so we see that most of the permits are coming for conifer forest, which is no surprise in this region. And then we see that, a lot of in-cone, not allowed burns according to the 2025 Pilot 2.0 program. Several of these permits would have been denied because they would not have fallen within that pilot. So we're just doing this to kind of get an idea. If we go back and look, how much emissions are we saving, or how many emissions are not passing over the sensor now with these new rules in place? So this is kind of a fun figure. So this is going through every single day during burn season from February 1st to the end of April. And it is looking at if we apply Pilot 2.0 rules to every permit that was pulled, was it allowed to burn under the Pilot 2.0 rules, which would be a circle, or was it going to be denied, which would be an X? And so as it's ticking, it's showing the actual emissions. Now, I should say this is total emissions from the entire fire. This is not necessarily what's hitting the sensor. A lot of the smoke rises up and moves out. But you could see as permits are getting denied by the pilot program, these are the simulated allowed emissions. So these are just the emissions that would have happened under the pilot program. Because some of those burns in the cone especially would have been denied. So we are taking kind of the edge off the amount of emissions that are being emitted. And I will say that one of the things we're working on implementing right now is, in all likelihood, if a permit would have been denied in the cone, they would have burned it another day when it was outside the cone, or the weather would have been permissible to do so. But we haven't had that modeled quite yet. But this is just, do we have everything working? Is LANDFIRE working correctly? Are we getting the correct fuel loadings? Or should we add in another fuel loading category? So this is just kind of an exploratory phase right now, but I thought it was really interesting just to show what we can do with the LANDFIRE data sets. And this is the same, I included this figure. It's showing the same information, just in a static figure. I always like to have a backup in case the animated ones don't work in PowerPoints, as they frequently don't. But this is just showing, as we go through burning season, this is how much emissions are being saved by being denied in the cone. So this is kind of what we like to see. It's taking the edge off the emissions, but it's not stopping burning completely. Because like I said, we're trying to find a balance. So what is the future of the Albany Pilot and our research? Albany Pilot 3.0 started January 1st. We made some minor tweaks to it. If you were able to see the flow chart, there was a 24-hour PM 2.5 value. And if you couldn't see it, don't worry. The Georgia Forestry Commission has this on their website, and you could go look at it if you're curious. We replaced that with a 6 a.m. hourly value. There were some instances where the airshed cleaned out overnight and a really good burn day went to waste. And it was also kind of hard for the dispatchers, the people you call into to get your permit, to describe, why we're doing it. So we thought a 6 a.m. value would be better. I have an asterisk by it because this is likely going to change. Sometimes the 6 a.m. values aren't in by the time permits are being issued. So we might bump that back to 4 or 5 a.m. just to give the data some time to populate in the system. But one of our goals is, we've gotten great engagement across all agencies, private landowners, And we really believe that this can serve as a national model on how to engage multiple partners, people that have different interests in, smoke management or fire management. And again, we're going to continue modeling this Albany pilot analysis using LANDFIRE data. We're starting some smoke plume modeling and just more detailed emissions modeling so we can really fine tune the program a little bit more. And all indications are that we're going to keep going with this. I've frequently said that annual average has been lowered to 9. Another question I get is it's going to stick, because there's been a lot of talk about rolling back some of these regulations, and it looks like it might get rolled back, but we have such momentum with this project. Georgia Forestry Commission's behind it. The local land managers are behind it, that we're going to keep going with it, and we're going to keep tweaking it. And we're really, because we're concerned, like I said, we breathe in the air ourselves. So we really want to come up with better smoke management practices, and we're in a pretty great testing ground to do so. So we're going to keep going, and there will be an Albany 4.0 in 2027. So that is my presentation. And with that, I can take any questions or open it up to the broader LANDFIRE team. So thanks.
Thanks so much, Holly. That was really informative and interesting. And feel free to keep sharing your screen if you want, because I'm imagining people might want to pop back over to any of your slides because they were very interesting. So if anybody has a question, feel free to just come off mute and ask it, or you can also put it in the chat. You're a pretty small group, so no need to raise your hand. Just feel free to chime in.
Hi, Holly. This is Jim Smith with the Nature Conservancy and the LANDFIRE group within the Nature Conservancy. And I can picture this because I grew up in Albany. Albany's my hometown where I grew up. So I've been on Pineland. I've been to all these plantations and things like that. So I can picture this well. And I'm sorry I was a little late joining your webinar. So my interest is I wasn't quite certain how you saw this to be applied. Would it be applied by a local organization or something for their own purposes, or the state permitting agencies, or how would you see that this is actually going to be applied?
Yeah, that's a great question. So, like I said, we've been working really closely with the Georgia Forestry Commission, and they and the regional EPA have been interested in how well this performs, and maybe rolling it out to some of their other monitors and some of their other locations that have similar issues. Like it's more prescribed fire-based than anthropogenic causes. And so that's where we're kind of looking at. But we have had some interest in other groups that are interested in managing their own smoke that way. But yeah, it would be like right now it looks like GFC and maybe the regional EPA have the most interest.
Okay. All right. Thank you.
I'm going to launch a poll really quick, but feel free to come off mute, anybody that wants to ask a question.
Yeah. Hey, it's Jeremy Kolok. I'm off the Hoosier National Forest in Indiana. And so I was kind of curious, could you go into some more detail what the added restrictions were for if you fell within the cone on that day?
Yeah, I can go back to those slides. So basically, it has to do with the fire weather. And so if you're within the cone that day, if transport winds are low, I mean, like 5 miles an hour or less, that means that it's just kind of stagnant. And admittedly, this probably isn't a great burn day to burn anyway. Most land managers probably won't burn when you have a low transport wind speed. Or smoke dispersion, which is a measure of how fast that smoke's going to go out. So this is going to restrict silviculture or land clearing burns, because in the state of Georgia, actually agricultural burns don't need a permit. So that's why it says just silviculture or land clearing burns. But basically, if it's already bad, you're not going to be able to burn. And then if your transport wind speeds kick up to 6 to 8 miles an hour. So that was kind of chosen because we're looking at the 30 miles around Albany. So the idea is if you're on the very outskirts of that 30-mile buffer, that if you stop your burning by 2 p.m., because that's one of the things in here, they're asking you to stop all your burning operations by 2 p.m., that if you have a transport wind speed of 6 miles an hour, it's going to move out of the city before nighttime. Because that's one of the big concerns is that's when we're seeing a lot of the PM spike is at night as, the sun goes down, your boundary layer settles in, smoke can get trapped at the surface. So that's kind of why they allow some fires to occur when you've got that 6 mile an hour transport wind or to 8 miles an hour. So the idea is, again, to let the smaller landowners burn that 25 acres or less, because it's just incrementally adding smoke to the airshed. And then as you go to this tier 1 and tier 2, so as your transport winds get higher, your smoke dispersion's higher. Basically, this means that your smoke is not going to blow horizontal, it's going to go vertical, it's going to go up and out. So that's why they're opening up more and more acreage to be burned. And then if you're, outside that area, it's just basically, again, if you have low transport wind speeds and low smoke dispersion, it's just a bad burn day. They're just trying to protect the whole airshed at that point.
Copy. So that smoke dispersion where it says, 40 to 69, 21 to 39, is that like a local smoke dispersion index or the ADI or?
Yeah, it's the ADI. They're getting it from the National Weather Service.
Okay.
So they're doing a poll at 6 a.m. every day to see what the forecast would be at 2 p.m. So that's what the local and regional dispatch is doing in Georgia. They're getting that fire weather data from NWS at forecast for 2 p.m.
Thank you.
Mm-hmm.
Thanks for the question, Jeremy. Who's next?
Hi, Holly. This is Randy with the Nature Conservancy's Landfire team. A couple broad questions. One, just did you have any observations about landfire data in terms of, did you see anything that you needed to adjust or getting feedback? And just moving to the future, I'm kind of queuing up a question from Megan that will be in a poll if it's not already there. Like what could we do to improve delivery, data format, that sort of thing for you in your process. And now just comment to say I'm not a land manager myself. I'm more on the data side, but to me, this just seems super common sense and easy to follow. So I can't wait to just track it over time. Hope to hear from you again with your modeling results and just what you guys learned. So it looks really cool to me. I just was curious about your use of landfire data and how well it performs.
Yeah, so sometimes with land fire data, you get it in any data set. We really took a look at what results we were getting because, sometimes it's like, oh, Arctic forest. No, that's not Arctic forest. So we would just be like, in case it's something that doesn't belong there, it's usually just a pixel by itself because, this is, as this is high resolution data. And it's an algorithm, so every now and then it would air out, and we just put safeguards in place. We're like, okay, well, these are the land covers we expect to see. So we did literature research, but like I said, this is kind of our playground and testing ground, so we know what's out there. And some people that work for me, Hannah Schley and Chris Matichek, they helped me with some of this work. They went very carefully through and they looked at everything and they applied some caveats. It's like, okay, well, if you have a pixel that definitely does not belong, go to the nearest neighbor and pull that in because that's going to be more representative. So like I said, that happens with every data set. You should always double check your work and be careful. And then as far as ease of use, it's been easy to use. Like I said, we like how it's divided into strata. So we're able to pull in like, oh, we don't want crown, but we want litter lichen moss, or we don't need this fuel type, but we need this fuel type. So it's really easy to pull that in together. But that would just be the caveat. I would say just, double check your results. You shouldn't take any data set at the surface. Just make sure something makes sense. And then, go from there.
I have a question. This is Gil Grzyski, Georgia EPD. Just something in the future. Like you have this program, and I guess it's kind of like with the permits and restrictions and all that. If someone burns anyway, is there any enforcement mechanism, or is this a voluntary kind of thing when it comes to this type of stuff? Like, in terms of behavioral change, is it just trying to incentivize behavioral change without enforcement?
Well, part of it is when you burn with a permit, you're supposed to get a permit and you have protections when you get a permit. So if something happens, you're protected legally under a certain, I can't remember exactly what the rule in Georgia is. They have one similar to Florida, like a right to farm bill. But if you don't get a permit, if you get denied and you burn anyway, and then you cause what's called a super fog incident where your smoke and fog meet on the roadway and create an accident, you're fully liable for that. You don't have those protections. You can also get in trouble with the Georgia Forestry Commission if they do spot a burn and you don't have a permit pulled for that. You can get, my understanding is somebody on the line might be better able to talk about that, but you do get restrictions. You can get sanctioned for that. I think you could get fines. You have your certified burner certification pulled in some more extreme incidences. But yeah, if you don't burn with a permit, you're burning without protection.
Holly, thanks so much. Really great presentation. It was super interesting. I'm curious about whether you're looking at trade-offs. So you're showing that inside the cone, you're getting less emissions, but you're also burning less. So you're not achieving some other objectives that you might have for land management, like wildfire risk reduction or restoring forest health conditions. And so I'm wondering if your team has kind of quantified that trade-off over time, how you might improve air conditions, but have fewer other benefits associated with burning?
Yeah, so that's a great question. So the example I showed was kind of our getting started point. So it was 2023 data, but realistically, and what we saw happen in 2025 is that if people were denied a permit on one day, or a lot of it, they knew that they would get a permit, so they didn't even bother because they knew the cone was over them and it was a bad burn day. They burned another day that was better. So the data I showed, we haven't yet got to the point where we reassigned the denied permit to a burn day outside the cone, but that's what happened in 2025. So if they needed to burn a particular day and they were in the cone and they weren't able to burn, then they would burn a following day where they were out of the cone or the weather was better. So actually during the same period, that February to end of March of last year, they burned 5,000 more acres than they have previously. And talking to the local land managers, he was on earlier, I don't know if he's still on, Clay Sisson, he works with Albany Pilot Project. He was in constant contact with all the local land managers. They actually were done burning by the end of March, which is historically early for them. So everybody got their burning done. They just switched the times they were doing it, and it actually lowered what was hitting the Albany area. So, that's, not quantitative, that's qualitative success. So we're in the quantitative part of it right now. But yeah, the examples I was showing, we didn't shift the burning, but I'm trying to logic out how we could show that.
Great, thanks.